My name is Marlon Etchery. I'm from the Natural Social Science Multimedia Lab at Miami-Dade Kendall. And today we're going to be learning about valence electrons. At the end of this video, you should be able to look at the periodic table and for any given element, determine the number of valence electrons. So first thing we got to discuss is what are valence electrons? So we should start with a definition. The definition of valence electrons is the number of electrons, and for notation purposes I'm going to be putting E minus, and that will mean electron. So it's the number of electrons in the outermost or valence shell. So the valence electrons are the number of electrons in the outermost or valence shell of an element. So if we want to get a better idea of that, we can look, for example, over here at potassium. If you look at potassium, potassium has a total number of 19 electrons, correct? But we're not interested in the 19 electrons. We're only interested in the outermost electrons in its valence shell. So how do we determine that? Well, you just simply have to look at and see what group it's in. Potassium is in group 1A. Okay, so then that would mean that it actually only has one valence electron. So let's go ahead and take a closer look at how that would look. So potassium has those 19 electrons that we just finished describing in a certain arrangement. I'm going to draw an image of that. I don't want to go into too much specifics, but just understand that it is layered. There's inner layers, and then there are consecutively layers that start to build on the outer side, on the outside. And then here's the one electron that I'm very interested in, the outermost electron. That is my valence electron. That's the one that we're interested in. So that's the general idea, that you're looking for only the outermost electron in order to explain the number of valence electrons. Why don't we look at the periodic table and try to figure out the number of valence electrons for a few other elements. We could try magnesium, for example. Magnesium is in the 2A column, so then you would be able to see that magnesium has 2 valence electrons. If you look at chlorine, for example, chlorine is in column 7A, so then you might assume that chlorine would have, if you were thinking 7, you would be correct, 7 valence electrons. That's the idea. So I think you're starting to see the idea. In order to figure out the number of valence electrons, you simply look at the group number, and that will tell you the number of valence electrons for that element. A group's Roman numeral will help you identify the number of valence electrons. Next, we'll be providing you a slide with a few questions, and then the next slide will have the answers following. The next thing we're going to do is we're going to start looking into the octet rule, and we're going to see how valence electrons tie into that concept.